Hello? Hello everyone, today we will continue with the course on HCI storage. Previously, we have already introduced the basic structure of hard drives. Today, let's take a look at, regarding hard drives, the most important aspect is storage, right? Capacity is the most important. So first, what does the capacity of a hard drive depend on? It relates to what we discussed in the last session. Cylinders, heads, sectors, and so on are related to this. Here, we can first take a look at this formula, which is quite long. Our formula is like this. The capacity of the hard drive is equal to the number of cylinders, multiplied by the number of heads, then multiplied by the number of sectors, and then multiplied by the size of the sectors. It's actually quite long, and the unit is generally terabytes or gigabytes. Here, the factors that mainly affect our hard drive capacity are primarily the capacity of a single platter and the number of platters. Here it's like a table, right? You should still have an impression of it. In the last class, we actually already mentioned that all our platters with the same radius delay form this cylinder, which is our cylinder. It mainly determines the actual physical location of our data storage. Yes, the actual physical location. The read-write head corresponds to each platter, and it is responsible for reading and writing data. The sector is the smallest storage unit of our track, usually 4K. So when calculating here, you multiply these four values together. For example, let's say a hard drive has 1,000 platters, 4 read-write heads, 100 sectors, and each sector is 512 bytes in size. What would the capacity be? You can calculate it by multiplying these four values together. 1,000 times 4 times 100 times 512 bytes, which is approximately equal to about 200 megabyte. About 200 megabyte. The capacity calculation is simply multiplying these four values together. There's not much technique involved, just multiply them. It's cheap. If you encounter larger numbers, you can use a calculator. Cheat. This is the method for calculating our capacity, specifically the capacity of a disk. If we want to increase our storage capacity, the key lies in two main points. The first point is the capacity of a single platter. In this case, we can increase the data density, for example, through perpendicular recording technology or including any other methods that can increase our data density will work. Here, it's not about making the hard drive larger, but rather increasing the density within the hard drive, while keeping its size unchanged. The capacity of a single platter in the earliest days, even 1 GB, was considered quite large, which was something from the last century, right? Back in the last century, a 1 GB disk was already considered large. But now the capacity of a single platter can reach much more. It can reach 2 TB. 2 TB is the capacity of a single platter, not the total capacity of the entire hard drive. It's the capacity of one platter that is 2 TB. The number of disks is also an important point. The number of disks here, our normal 3.5-inch hard drive, can hold up to 5 disks. So the capacity is generally about 20 TD. The capacity of 20 TBB can also be increased by increasing the number of disks. Hey, increase the capacity of our single disk. This is us. The capacity of the hard drive. Calculation. Besides the hard drive, another very important aspect, apart from storage, is the cache. Since the read and write speed of hard drives is limited and cannot keep up with our memory, we need something here. We need a cache to assist. Here, the processing speed of the CPU and the read-write speed of the hard drive actually have a difference. A difference of over 10,000 times. So, our cache acts as a high-speed temporary storage area to prevent frequent data access and reduce the CPU's waiting time. The working principle of our cache here is actually data is first stored in the cache and then written to the hard drive in batches. And when reading, it pre-reads data from adjacent sectors to accelerate continuous access. Regarding the impact of cache capacity here actually. Generally, a smaller cache of 64 megabytes is sufficient. It is generally suitable for sequential read and write scenarios, such as backups. For larger storage, if you use a large cache of over 256 megabytes, for instance. First, let's take a look. The internal transfer rate mainly refers to the data transfer speed U between the disk's read-write head and the platter, which primarily reflects the disk's own read-write performance. Here, it's actually equivalent to what? It's equivalent to the internal production speed of a factory's production line. As for the external transfer speed, it's actually like the hard drive connecting through an interface to external devices, such as other hosts. Or the data transfer speed between servers or computers. What affects it? It's mainly limited by the type and performance of the interface. For example, like a USB interface, right? Or like a SATA interface. The transfer rates of these different interfaces are not the same. This is actually the different transfer rates. As for the influencing factors and application scenarios, the main points are: in terms of our data transfer here, firstly, the internal transfer speed is influenced by factors such as our disk rotation speed, magnetic head technology, data density, and so on. There are actually quite a lot of these factors, which are the various influencing factors inside our disk. After we sum them up, we arrive at such an internal transfer rate. Generally speaking, the higher the disk rotation speed, the faster our internal transfer rate. This is the most basic and simplest influence. Secondly, there is our external transfer rate. This mainly depends on the standard and performance of our interface. For example, let's take one of the many interfaces we introduced earlier, like the SATA interface. As for the SATA interface, it actually can be used with our mechanical drives as well as solid-state drives. The SATA interface mainly, well, nowadays there are different versions. For instance, the current SATA 3.0 version, its transfer rate is much faster than that of SATA 2.0. This shows that different interface versions have varying speeds. However, in practical applications, if we need to quickly read a large amount of data from the hard drive to the computer or to the server, what is more important? Actually, the external transfer rate is more important. If we are organizing or storing some data internally on the hard drive, then the internal transfer speed becomes more important. So, it's not necessarily that both need to be extremely fast, it depends on different situations. If the disk frequently reads and writes and interacts with external sources, then the external transfer rate is also very important. If it's just for regular internal storage, then having a fast internal storage is sufficient. These are our two types of transfer rates. You can compare these two methods of data transfer. The internal transfer rate is essentially the inherent capability of the hard drive itself. Its improvement relies on advancements in the hard drive's own technology. Whereas the external transfer rate acts as a bridge for communication between the hard drive and the outside world. The width or narrowness of this bridge actually determines the speed at which data enters and exits. Only when both the internal transfer rate and the external transfer rate are fast enough can the overall data storage system's transfer rate reach its optimal level. This is our comparison. A comparison of the two rates. That is to say, if you need both internal storage and frequent read and write operations with external sources, both need to be fast. Neither can be a bottleneck, as any lag will affect the overall speed. This is about our disk. The average access time and the data transfer rate, these are the two main aspects. The main point is that everyone needs to understand that these two influencing factors are not singular. Whether it's the average access time or the data transfer rate, they are not determined by a single factor. You can look into it further on your own. Take a look, for example, at the differences between solid-state drives and mechanical hard drives in terms of average access time, internal transfer rate, and external transfer rate. You can see how significant these differences are. You can take a simple look to understand this better. This is what we are discussing. These two are also considered two very important metrics for our hard drives, important indicators in terms of transfer. This is the content of our lesson. Enhance your learning. If you are serious about Huawei certification or want to obtain the Huawei certification question bank, please send me a private message. You can also leave a comment below the video for technical exchanges. Alright, let's stop here for today.